Now on the periodic table, the one way in which elements are classified is by groups. So group 1A, so first of all, the vertical columns, these are known as groups. The horizontal rows are known as periods. Okay, horizontal rows are known as periods. Now, the first two groups put together, they're known as main group elements, along with these last 6 groups. So group 1A, 2A, 3A, 4A, 5A, 6A, 7A and 8A. These are known as main group elements. Then the block in between is known as transition elements, the group of transition elements. Now, this specific two groups is known as the S block, and I'll tell you why they are known as S block after some time in another chapter probably. This is the D block, and inside this D block somewhere here, and we'll talk about that again when we go more detail into periodic table. Somewhere here, okay, here in this area is the F block, and you can tell it's right here because the atomic number jumps from 57 to 72. Atomic number jumps from 89 to 104. So there is something here in this area. That is the F block, and this is known as the P block. Okay, this is one way of classifying main group elements, transition elements, S block, P block, D block and F block elements. Okay, we will go over these in very much in detail in later chapters. For now, you just need the overview of it. The second way of, or the second method of classifying elements on periodic table is classify them as metals, non-metals and metalloids. Metals, non-metals and metalloids. Okay. Now, what are metals? Metals are good conductors of heat and electricity. They can be pounded into flat sheets. They can be drawn into wires. And these properties are known as malleability and ductility. Malleability means they can be made into sheets. Ductility means they can be drawn into wires. They are shiny. Okay. Why are we talking about that here? Metals are on the left side of the periodic table. So these are all metals. All these are metals. Okay, and if you remember from the previous slide, there's another separate block here, and all those, they're all here, and so these are all metals. These are also metals. And typically, these are non-metals. Okay, these are non-metals. And what are non-metals? Non-metals are not shiny. They are not good conductors of electricity or heat. Okay, they are not shiny. And what are all the non-metals? These are all non-metals. Carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine, selenium, bromine, iodine, helium, neon, argon, krypton, xenon, radon, and hydrogen. Very important. Don't forget hydrogen. This is a non-metal. Just because it's on the left hand side don't think that it is metal. So these are all non-metals. Let me just use a different color so you all will see it. Non-metals, okay, and these are all metals, and in between here boron, silicon, germanium, and arsenic, and antimony, tellurium, and acetylene. So these on either side of the ladder, okay, I don't know if you can see this clearly. Just to make it more clear, let me just use another color. Boron, silicon, germanium, antimony, tellurium, acetylene, arsenic. These are all metalloids. So what are the differences between metals, metalloids, and non-metals? Metals are shiny, non-metals are not shiny. Metals are good conductors of electricity, non-metals are bad conductors of electricity, except for carbon. If you want to make a note of that, carbon is a non-metal, but it's a good conductor of electricity in the form of graphite. Okay. Non-metals are placed in between good and bad electrical conductance, which means they are semiconductors of electricity. They are semiconductors of electricity, and they lie on either side of the zigzag diagonal line that separates metals and non-metals. At any given time, when a chemical symbol is given to you, you should be able to identify if it's a metal or non-metal or a metalloid. Okay, so remember the zigzag diagonal line.